Hello, today I will be talking about the periodic trends. There are multiple atomic properties that depend on the periodicity of an atom, and periodicity is basically the placement of the element in the periodic table, which is determined by the atomic number. These periodic properties include ionization energy, electron affinity, atomic radius length, and electronegativity. We can predict the relative values of these properties by studying their trends over their periodic table. Additionally, it is important to note that there are some exceptions to some of the periodic trends, and that these periodic trends are used to generalize and not to be extremely specific. The most important periodic trend for us to discuss first is atomic radius, since it explains so many of the other periodic trends. The radius of an atom greatly depends on the number of electrons present in the atom, since as the number of shells increase, so does the atomic radius. The trend is generally that the radius increases as you go down a group or from right to left in a period. Coulomb's law. Coulomb's law generalizes the formula for the Coulomb force, which indicates the strength of the attractive forces between electrons and protons in an atom, and takes into account the distance between the electrons and protons in a numerical form by using the principal quantum number n. Coulomb's law allows us to predict ionization energy and electron affinity in a manner by using the effective nuclear charge and the principal quantum number. This law shows that as the atomic radius becomes bigger, the less attractive forces there are in the atom. As you can see, the charge is divided by the distance, which means as the distance becomes bigger, the smaller the force is. Nuclear charge. The effective nuclear charge gives us a simplified identification for how strongly an electron is attracted towards the nucleus. The stronger an electron is attracted to the core, the more energy is needed to allow it to escape. The effective nuclear charge depends on the number of valence shell electrons, and therefore it increases as you go right in a period. Effective nuclear charge is often symbolized by the symbol ZeF, and it is calculated by subtracting the total number of protons in an atom by the number of inner electrons. So in this case of the sodium atom I have shown over here, you can see that the atom has 11 electrons, which means it has 11 protons. But there is one singular electron on its own over here in the outer shell, which means sodium has 10 inner electrons, and when you subtract 10 from 11, you'll be able to get that the sodium atom has one positive nuclear charge. Shielding. Shielding is the process by which the attraction of valence shell electrons to the nucleus is reduced by the presence of the inner shell electrons. This is due to the repulsion forces of like charges between the valence and inner shell electrons. The larger the atomic radius, the greater the shielding effect, as it increases the amount of inner shell electrons. And this drawing basically shows how the outer electrons are repelled by inner electrons. So basically this means that shielding decreases as you go left to right in a period like this, because the amount of electrons are increased while the amount of shells stay the same. But shielding increases as you go down a groove like this, because of the amount of shells increase. Now on to ionization energy, which is the energy that is required to remove an electron from an isolated atom or molecule. The ionization energy increases as you go up in a group due to the atomic radius getting smaller, and therefore the attractive forces on the outer shell electrons increasing, making it harder to remove them and ionize the atom. It increases as you go right in a period, since as you increase the outer shell electrons, and therefore the atom is less likely to donate an electron and is more stable when it accepts an electron, and as a result requires more energy to ionize. This table over here basically summarizes how when the atomic radius is larger, the easier it is to remove electrons. Electronegativity is a measure of the tendency of an atom to attract and hug an electron in a shared pair. And this is a drawing that shows how electronegativity can be simplified to be how attractive electrons are to this atom. The trend generally states that as you go down in a group, the electronegativity decreases because the increased number of energy levels puts the outer electrons very far away from the pole of the nucleus. And as you go right in a periodic table, the electronegativity increases because the closer the valence shell is to full, the stronger the pull of that atom on the electrons in a bonding pair. Now on to electroaffinity. Electroaffinity is the amount of energy change that occurs when accepting an electron to the atom in the gaseous state, forming an ion. And this drawing basically shows how when an atom has high electroaffinity, it is more likely to accept electrons, and when that atom accepts an electron and releases energy, it is more likely to accept more atoms. In a group, it increases from the bottom to the top because each atom is larger than the atom above it. This means that the added electron is further away from the atom's nucleus compared with its position in the smaller atom. With larger distance, the force of attraction from the electron to the nucleus is relatively weaker, and thus electroaffinity decreases. In a period, it increases from left to right like this because since atoms become smaller and as the forces of attraction become stronger, this causes the electron to move closer to the nucleus, thus increasing electron affinity. Thank you for listening.